Hey, welcome to Library Sherry, and today I want to talk a little bit about why some of your hematology lab orders takes a little bit longer time to get a result back to you. Actually, maybe not just a little bit. Sometimes it's taking up to like a whole day until you get the result. Let's start with how we process things over there. So if you send us a blood sample, actually we're gonna talk about the body fluid later on. Let's talk about the blood first, because this is like a more commonly what we receive in the hematology for testing. What you guys want to know is like the white count, the red count, specifically hematocrit and hemoglobin level, and then platelets. Occasionally, if you are looking for some signs of infections, or if you got a cancer patient, you want looking at the differentials of the white cells. Well, here's the thing. When you send it to us, the first thing we do normally is just throw right on for the Sysmex to do the initial running. And there are two things could happen over here. If everything looks fine, you will get your results super fast within 5 to 15 minutes, depends on how many samples we receive during that time period. But the actual analysis itself on the analyzer, it doesn't take that long. It's only a few minutes. The things getting difference is from when the sample is a abnormal sample. What I mean by that is, think about this. Like every single analyzers, it got some sort of like methodology to read the result. And that methodology of deciding whether this result is suspicious or not is based on a statistical, it's a statistical range. Let's put it that way. So if sample is within this range and all the signals are clear, then the analyzer will be happy to release everything. But then if you are not within this range, well, now things start getting funny. So if you are having like a patient, for say, got even a critically low H&H, let's say a hematocrit of 18, that's critically low. But statistically, for lab-wise, we see enough of those samples. So when they're setting the analyzers, this is not a rare result. So for it, okay, it's just a critical. We've seen plenty of them, will give you the result. Things only becomes a problem when your patient is maybe having a hematocrit of 8. Now, if you're a new provider, might be a very extreme case. You would think, oh, this shouldn't be happened. Nobody's hematocrit is 8. But yes, it does happen. If you work in the lab, you'll realize once in a while, it's very rare. I might be see like 2-3 cases like this through my entire whole decades of working experience, but this kind of patient do exist. It happens to some patient with like extreme anemia, and for a long term, sometimes you will see them. So what happens to this kind of sample is the analyzer doesn't even recognize this is a human blood. It's way out the setting range, so it will alarm. And then this is the time we need to take extra steps. We need to step in, adjust the settings, and try to make the analyzer read your result. And this will take time. But I mean, this is a very extreme case. You're saying, well, I'm not having, like, I don't always having a patient that having an 8% hematocrit, right? that's hopefully that's not a common situation for you. A more common situation is actually the sample turbidity. So our analyzer in hematology, it's called Sysmex. The way how it reads your sample is shoot a light from this side, and then it goes through a cell, and on this side there is a detector. So what this detector read is like how big is this cell, how complex is this cell, and how many of this pass through. So that's how you get the red count, the platelet count, the white count, and specifically what type of white cells in there. If the signal is clear, then you got a automated differential just release right across, and you get your result really fast. But what can blur this reading? One of the things is when your sample getting turbid. If your patient is on propofol, a lot of patients in OR or ICU, they are on propofol. So when their blood goes through this channel, And when the light hits it, and the other side, the detector will be like, this signal is really blurry, really foggy because all the propofol in the blood. So in this case, it will give us a whole bunch of abstracts, and that's the time we need to move of course, like the first thing what we do is always trying to put it back on, do a rerun just to make sure it's not just a random glitch. It's like how you reload some of the web page when it doesn't be loading right. The first thing you do is not trying to get a new computer or like run a antivirus software. The first thing you do is always trying to refresh web page first. That's what we do in the lab too. So we will try to rerun it. So this is add some time for it and trying to see what the rerun looks like. And if the pattern looks the same, it's still like having the abstracts and the numbers reading the same way, it's just weird. This is time we start deciding, well, if this is a turbid sample or if this sample got some agglutination issues or something is making the signal or the light signal not clear enough to read. So now what happens is we'll try to warm the sample up and try to see if just the cold agglutination causing a bad signal. What a cold agglutination is, some of the patient's blood, when they've been removed from their body, your body is 37 degrees Celsius or 98 degrees, whatever you want to use Fahrenheit. I know a lot of you guys working on the floor, you guys are using Fahrenheit, which is patient friendly, but if you're working in the lab, but in the laboratory settings, we are very rarely using Fahrenheit, we use Celsius. So when your patient blood removed from the body, it becomes room temperature, like 70 something degrees in Fahrenheit, 22, 23 degrees in Celsius. Some patients' red cells, they clumps like this. When they all clumping up, when they pass through the same way, imagine the light shooting through and the other side, what now the detector getting is like there is a huge, like weird scatter light just hitting on the detector. So the detector being like, what the hell? What do you want me to read? So in that case, it will also create a blurry, weird signal to our analyzer. So now, for us, by staring at that tube of blood, we can't just immediately tell if it's agglutination or propofol or extreme lipemic. Like some people, when they get the genetic issues or some other whatever happened later on in their life, they got so lipemic, and that's the strawberry milkshake blood. So in this case, what we do next after we do the rerun is we dump them in the water bath, 37 degrees Celsius water bath. After a few minutes, normally it will be 20 to 30 minutes. Yeah, it's that long. After we get everything so warm, and we rush over to test it again. And now there are two things could happen. One, if your patient is actually a cold agglutination patient, by warming this blood up, you will get the result coming back to you. Woohoo! Yeah, we all love that. But the other thing could happen over here is if your patient is actually lipemic, extreme lipemic, not just a little bit, like extreme ones, or if your patient is on propofol, the high dose propofol. These two scenarios are not resolvable by warming the blood up. There's nothing to break off, it's just blurry, foggy reading. So in this case, you need to move everything to bench. All the hematocrit need to be done by hand in our little centrifuge in a small tiny glass tube, and then we measure how much blood in that little tube, give you a percentage of that, and recalculate a lot of things manually. And the worst part is you need to do the differential count on the counter under the microscope, and until we cap 100 cells. That's the most standard setting. If your patient got extreme cases, leukemia or leukocytosis, those kind of situation, we might have to count 200 cells or maybe as low as 50 cells. It depends on the case. But typically, if things get moved onto the bench, it will be a little bit slower because everything needs to be done manually. Imagine this, if we can do the blood through the analyzer, when you just shoot a stream of blood through a tunnel and then a light goes through and the other side just a detector to read all the signals, electronic signals can be fast. All right, it's faster than human eye and finger clicking. So in that case, yes, your differential will be really quick. Your all this, that, and readings will be very quick. But once we move things down to the bench, everything needs to be done by our fingers, by our eyes, and we need to adjust the microscope to find focus and get all the cells focused. That's gonna be slower. That's not too hard to understand, right? And now, but is that the end story? No, actually not. So here's the thing. When we put the slides under the microscope to read, there are 4 things can happen again. So first one, all the cells looks happy and healthy, nothing broken, nothing super odd or weird. In this case, we spent like a few minutes. If it's a new tech, student tech, it might take like 5 minutes or 10 minutes. But if it's an older one, more experienced one, it might be take only a couple minutes to read a whole slide for your differential. If everything looks, if all the white cells looks fine, nothing weird about morphology, this result will be getting out. You will get your result very fast. But then there are also 3 other situations you won't get your result immediately. First one is when we get the smudge cells, which means the white cells is broken under the microscope. So when we're looking at the cells, this is a regular cell. A smudge cell will be some broken. They'll look like this, which represent some medical conditions for your patient. So in this case, what we do is we will try to remake the slides with albumin and all that stuff. And the purpose is trying to minimize the amount of broken smudged cells. That way we can give you a as accurate as possible count. And some hospitals might give you a disclaimer. Some hospitals might count in the smudge cells percentage or in there, and then give you a disclaimer in there. And then you can know this is a signal, like you need to pay attention. Normal people, they shouldn't have their white cells all just be broken under the microscope. If you didn't make the slides right, some of those mechanical force might be like broken some cells, but it never should be like maybe 40% cells broken. That's not something about how we make the slides. It's something about the patient's cell itself. Like blood cells is one of the cells extremely easy to be broken. So if we got something like at more than 10%, like if it's up to like a 40%, 60%, they're all broken cells under the microscope, I mean the white cells, then there is an issue, all right? So this is the time we need to remix the slides with all the different things. And let me tell you, the albumin slides, when we add the albumin into the human blood and trying to remake the slides are drying a lot slower than a regular slides. So it takes like up to like half hour to an hour extra time when we do that. So what's the other situation could happen is this is the one you want the least amount because you will end up with a redraw. This is when we put the slides under the microscope, not very often, but occasionally, we would find huge, like gigantic platelet clumps under the slides. And that signal, for some reason, did not getting picked up by our initial analyzer, the Sysmex. And half of the result already released. But if we find the platelet clumps, the gigantic platelet clumps, what we mean, like if we got the platelet clumps, like each tiny clumps only clumping in like 3-4 platelets, that's the time we will just give you a disclaimer or don't even mention. We just being like, yeah, it's just very unlucky situation. But if we got the clumps that we see, there are like maybe 50, 100 platelets, they just clumping everywhere on the slides, and some reason the initial Sysmex analysis did not pick it up. This is time we go back and then pull back all the result, fill in all the safe report and all that stuff, and then tell you, unfortunately, everything I released to you does not count right now. Like you need to do the blood draw again. It does happen. It's rare. I gotta say this, it's very rare, like maybe few times in a week it does happen. So you might be thinking like a few times a week is not rare situation, but if you imagine how many samples get into the lab on the daily basis, this is like maybe 1 in 1,000 or 1 in 2,000 of the sample. Well, that is rare, right? So it does happen. This situation, we hate it too, because we need to make phone calls. We need to fill in all those reports because a bad or wrong result was released by the lab. But this is not something you can blame on anybody, it just happens. Okay, so the last one. This is the one you will get the result on the second, or at least a half day later. If we see like a certain morphology, like for say, if we see blast, lot of blast, and this patient is like a first time having this situation happen, this is the time we'll send the slides into the pathology resident and be like, hey, like whoever get the MD, like you got the degree, okay, reread the slides, consult with the floor, and do whatever you need to do. Like this is the first time it happened to this patient, and it is not good. Any slides that ends up with a pathology review that you don't see a result 3-4 hours later, your patient got in trouble. Like I'll just put it that way. Your patient is in trouble. You might already know that, but it's not always like I can recall there was a patient, he coming into the ER middle of the night, just looks like just having a fever, a cold, all that symptoms. But when I was looking at the slide, it was flooding with blast. That was the time I paged our past resident and being like, you know what, dude, you are not sleeping tonight. And so this is everything what can happen and to delay your result for the blood sample. Okay, now we're finally getting to the body fluid. So in the body fluid situation, the first thing that causes a delay would be the workflow. Like if it's a nighttime, somebody would be probably distributing this sample to every department all at the same time. You probably don't have this issue. The more of what happening during the day and evening is this body fluid will be going to microbiology first because they require the sample to be very clean, sterile, whatever you want to call it, and they trying to make sure they are the first one touching the sample. That way you minimize the risk of containing in microbes in the sample and then affect the result for your diagnosis. So in this case, they would get the sample first. They won't even go into hematology first. And then the next department would be chemistry or hematology. It depends on different labs, but typically it would go to micro first. But then when hematology does get the sample, now what happens is we need to switch over the mood of our Sysmex. Yeah, same Sysmex that doing the blood samples. It can also does body fluid. The only problem is the settings for fluid will be so different from the settings that reading the blood. So the whole entire analyzer, it need to clean off entire line, clean off the entire sample line, like recalibrate the background and all that stuff. Those kind of things takes quite a few minutes to finish. So we need to wait for that to happen. If you're asking like why don't we just switch over the mood while like we get the sample, while the sample already in microbiology, why don't you just like doing all this preparation work first? We can't. We also have blood to analyze. We can't just like randomly took off a analyzer off the line completely. Yeah, it can happen if it's nighttime. We don't have like a 200, 300 samples waiting in the line of being processed. Yeah, we'll definitely do that for you. We'll switch the mood the second the sample even arrived at the central receiving without even going to the micro. We'll just already start to do all these preparations. But daytime and evening times, when we are so packed with blood samples, we will do the switching mood until we actually see the sample in the bench. Because otherwise, if we do that, that means another 50, 100 patient samples, blood samples, will be delayed. You don't want that happens, right? So in this case, we'll take some time waiting until our analyzer getting the right mode. So now when we actually do the analysis, remember I told you when your patient got the very extreme H&H readings, we need to like adjust settings and do all the extra extra steps to make you get a result. This happens with the body fluid sample too. So if your patient got a extremely high count of white cells in whatever the body fluid you gave us, especially if your patient got the infections going on, their white count in the body fluid is so high, it will make our analyzer having trouble to read, because typically our analyzer would think the body fluid would have a very low white count reading. So if your patient is like basically draining out like halfway past, then in this case our analyzer would be like all overwhelmed. So it will give us errors, all the abstracts, all the question marks, or whatever, those kind of flags. So in this case, what happens now is on the bench, we need to go to do dilutions, trying to get it back down to the readable range. While we're doing the dilutions, the analyzer itself, now it need to reflush all the line, clear off the background, and make it recalibrated, all that step. That takes a little while. And after it's all done, we repeat these steps again. And hopefully it becomes readable number. And if it doesn't, everything, all what I just said, just getting repeated. So this is on the analyzer, what can cause the delay of your sample. What else can do? Well, it's again the differential part. Anything that need a differential body fluid, it goes to the bench, and we do that manually. And if your patient was one of the ones that having high white counts, well, this is the step that we're happy with because it's easier to find 100 cells on it. But if you send us a patient that barely passed the threshold, or if it's a spinal fluid sample that having barely any cells in there, well, this is the time we need to chill the F down in front of our microscope and spending time to come, because we need to find every single cell. We generally need to give the microscope a good 10 minutes of stare to get the count. The main reason is, of course, because of the low cell count. The other reason is the white cells in body fluid, their morphology is very different from when they're in blood. So we need to be extra careful with what are we reading. We don't want to give you a wrong differential. It will most definitely direct your diagnosis to the wrong direction if we do that. So we need to be extra careful. Typically, if we do a body fluid differentials, it will be taking double amount of the time than we do a regular blood differential, if not longer. So that was the reason. And the last is, like, if we see weird stuff, do we send them over to pathology resident review? Yes, we do. We also send them for review. So in this case, you're wishing your result to be coming back in the afternoon if you send in the morning, and if you send in the afternoon, it's either coming back in the evening or it's coming back in the second day. So now, I know this video is very long, but if you are a provider, I hope you now understand a little bit better of why sometimes your hematology orders coming back slowly. Next week, I think I'm gonna talk a little bit about chemistries. Hopefully next week the video won't be as long as this one. But anyhow, thank you for watching. This is Lab Rat Sherry. I'll be seeing you next week.